Hi everyone. Today we will discuss two important aspects of the data link layer. The first one is flow control. The flow control coordinates the amount of data that can be sent by a sender before receiving an acknowledgement. It tells the sender how much data it can transmit. This usually happens because the receiver will be having a limited speed and a limited amount of memory to store the incoming data. Next is the error control, which includes both error detection and error correction. It allows the receiver to inform the sender if a frame is lost or damaged, and it coordinates the retransmission of those lost frames. This error control is commonly based on automatic repeat request or ARQ. We'll discuss in detail the different methods for the error and flow control. The first one is stop and wait. The second one go back N ARQ, and the third one selective repeat ARQ. First we will see the stop and wait ARQ method. Here you can see a sender and a receiver. The sender and the receiver will be having two control variables S and R respectively. When the sender sends a particular frame, it sets the value of S as 0, sends the frame 0, and on receiving the frame 0, the receiver sends back an acknowledgement. This acknowledgement will be marked as ACK1, which defines the number of the next expected frame. On receiving the acknowledgement 1, the sender will be sending the next frame, which is marked as frame 1, and this method goes on. During this stop and wait method, the sender starts a timer when it sends a frame. If the acknowledgement is not received within a particular allocated time period, the sender assumes that the frame was lost or damaged, so it sends again that particular frame. Moving to the next topic, which uses the stop and wait ARQ when a data frame loses. Here the sender sends the frame 0. It is successfully received by the receiver, sends back acknowledgement 1. On receiving the acknowledgement, sender sends frame 1, but the frame 1 was lost in between, so the timeout happens at the sender side. When this timeout happens, the sender sends that frame 1 again, and on receiving that frame 1 successfully by the receiver, it sends back the acknowledgement for the frame. Next, the acknowledgement can also be lost during the stop and wait. Frame 0 is sent by the sender, received by the receiver. Acknowledgement 1 is sent back to the sender. Sender sends the frame 1. For that frame 1, acknowledgement 0 is sent by the receiver, but in between the acknowledgement is lost. So after the timeout value, the sender sends the frame 1 again, assuming that the frame 1 was not received by the receiver, but the receiver has already received the frame 1, so it simply discards the frame 1 and sends back the acknowledgement again. There also happens the delayed acknowledgement during the stop and wait. Here the sender sends frame 0. After a particular timeout value, the acknowledgement for frame 0 was not received, so the sender sends again the frame 0. But after sending the frame 0, the acknowledgement for the frame 0 was received by the sender because of the delayed acknowledgement. On receiving the acknowledgement 1, the sender discards the frame 1 and it simply resend the frame 1. The receiver, on receiving the frame 0, again discards the frame 0 since it has already received the particular frame. On receiving the second acknowledgement, the sender also discards the second acknowledgement. Next is a concept called piggybacking. In piggybacking, the acknowledgement is not sent every time. Instead, the acknowledgement is hooked along with a data frame. Here, the sender is sending frame 0 with an acknowledgement 0. On receiving the value, the receiver sends back frame 0 to the sender along with the acknowledgement 1. On receiving the acknowledgement 1, the sender assumes that the frame 0 was successfully received by the receiver. So without simply forwarding a packet with an acknowledgement, the data frame along with acknowledgement is sent always, and this saves bandwidth. The disadvantage of stop and wait method is that only one frame is sent and it is being acknowledged all the time. This is not a good use of the transmission method. So in order to improve the efficiency, multiple frames are always sent, and two important protocols are used in this concept. The first one is go back N ARQ and the second one is selective repeat ARQ. First we'll see the go back N ARQ. Here multiple frames will be sent and the sender keeps a copy of all the frames sent. The receiver also keeps a copy of all the frames received. In order to accomplish the go back N ARQ, the header of the frame allows m bits for sequence number. Each frame will be having a particular sequence number. The sequence number will be ranging from 0 to 2 raised to m minus 1. Say if m is equal to 3, the sequence number will be marked as 1, 2, 3, 4, 5, 6, 7. This is how the sequence numbers are being done. We will see the method in detail. Here the window concept is used. A window allows a particular number of frames to be transmitted. Consider a window size 7, that means it contains frames 0 to 6. Always the frames inside the window is being sent. So at the leftmost end the frame 0 is first sent, then frame 1, then 2, and goes on. After sending the frame 0, the window moves right a 1 value. After sending the 0 and 1, the window moves 2 values towards right. So after sending each data frame, the window simply moves towards right, hence the name sliding window. At the receiving side, the receiver always have a single window to receive the data in this protocol. So it always looking for a single frame to accept. After accepting the frame 0, the window at the receiver side moves 1 position towards right and it will be expecting frame 1. 3 control variables are commonly used in this windowing concept. One is the S, which holds the sequence number of the recently sent frame. The second one is SF, which holds the sequence number of the first frame. And the third one is SL, which holds the sequence number of the last frame. And the receiver will be having only one variable R that holds the sequence number of the frame it expects to receive. On the sender side, as you can see, SF showing the first frame, F shows the recently sent frame, FL showing the last frame. So on the sender side, we have a windowing size of 3, which includes 0, 1, and 2 frame to be sent. At the receiver side, only one windowing frame is there to receive a single frame. This is the go back N normal operation situation where a sender having a particular window size which is equal to 3 will be sending data one by one. The frame 0 will be sent, frame 1 will be sent after 0, then goes on. After receiving each frame, the receiver sends back an acknowledgement. Here the acknowledgement 2 is sending back to the sender, and on receiving the acknowledgement 2, the sender analyzes that the 0th and the first frame was successfully received and the receiver is expecting frame 2. So the sender will be sending frame 2 after receiving acknowledgement 2, and this method goes on.